Welcome back. Given we're in the midst of a heat wave today here in Paris, we thought today was as good a time as any to bring you a weather-specific episode. With technology increasing the accuracy of weather forecasts each year, we are often asked here at Lokad whether this data can be used in order to optimize purchase decisions. Today, we're going to discuss where some of the complications can lie when combining different forecasts and understand whether this data can be leveraged in order to give us any valuable insight. So Johannes, it kind of seems to make sense a little bit on the surface, but what's the idea behind this?
So the idea is a simple one, is that there is tons of products that are highly, I would say, weather sensitive in terms of demand. You can think of maybe barbecue meat that you're going to buy for the next weekend if you know the sun shine and you're likely to do a barbecue. But more generally, there is entire classes of products that are highly weather sensitive. And to some extent, pretty much everything is kind of weather sensitive. I mean, even your car, if you're in a region that is very cold, you will not exactly pick the same car as if you're living in a region that is very hot or where it rains a lot, etc. So it is of interest to have this data, and obviously, because it's kind of an obvious factor, many supply chain practitioners think of, well, let's improve the forecast by trying to include this data from the weather, in particular from looking at weather forecast.
So, I mean, surely the more that you actually know, the better placed you are to make kind of a decision based on the future. So how well does it actually work in practice?
So that's interesting, especially the part about how does it work in practice. Because when I created Lokad 10 years ago, I would say weather data and with weather startups was all rage, literally. There was at the time, probably in France, there was 3, I think, startups that were all about refining forecasts with weather data, and there were probably something like 20 in the US. So it's interesting because that was a decade ago. That was literally one of, I would say, it was a small buzzword of its own, having everything that was like weather enabled or weather powered in terms of analytics. And thus, what is interesting that in practice, as far I know, it has remained incredibly niche. And even actually Lokad, we did quite a few missions for large companies about a decade ago, and it died down. The long story short is that it's way too much effort for what it's worth.
So what did we actually learn when we were putting it into practice all those years ago?
So, I mean, we learned quite a lot. I mean, we even did missions with a large European electricity provider, which I believe is exactly the sort of classes of company who are nowadays leveraging very efficiently weather data. So electricity providers are leveraging that weather data to predict electricity consumption so that they can really feed just enough what the grid need at every single minute of the day. Because, by the way, you cannot stock electricity, or actually there are ways, but they are, I would say, very inefficient, very slow, impractical in practice. So it's not like supply chain. You can't just build up your stock and drop your electricity afterwards. So that's why you need very precise forecast. But back to, I would say, weather data, what the key insights, I mean, there were many insights. One is that weather is just so incredibly complicated. I mean, people don't realize that it's such a many-dimensional problem. I mean, you have obviously the geographical grid. So one thing about the weather is that it's a super local thing. So and I was a bit surprised to realize how different the temperature can be just 20 kilometers apart. I mean, you can literally have 15 degrees of difference, 20 kilometers apart, because one place is just a kilometer higher in altitude compared to the other place. So you have super diversity in terms of geography, but then also it's literally the weather is not a thing for the day. I mean, the weather, when you look at TV, they will tell you tomorrow it rains, but the reality is that it rains tomorrow is that you will have like 5 rains of 10 minutes spread during the day. So it's a very precise thing that change literally minute by minute. So okay, you have the geography, then you have the time to a granularity that is like super thin. Obviously, it makes a lot of difference whether it rains during the night or during the day, these sort of things. But then the weather itself, it's not just about the temperature and whether it rains or not. There is like there is half a dozen of metrics, like do you have wind, what will be the humidity, how much light will you get, and will the wind blow at which speed and which direction, and will it blow continuously, extra. So it's a very many-dimensional thing. And as a result, I would say in terms of data, it's I would say a small world of its own. I mean, you're already dealing with all your supply chain data. It's already kind of very complicated. And then you just discover that there is this weather data set that is just next to your supply chain data. And it's something that is literally, at least it's not 10 times more complicated than all your supply chain data put together.
Yeah, so there's obviously these complications there, but they're complications that are very much dealt with. They're very much kind of collected. So what kind of technical challenges does that introduce? Because they're things that we kind of start to know now.
Yes, I mean, first, just think of it is that you end up with a volume of data, I would say, on the weather side, that is literally, 10 to 1 times larger than your supply chain data. So it's just that in terms of software engineering, you end up with something that was designed, to deal with the supply chain and its scale. And then you realize that if you want to deal with the weather data, that you need to deal with literally 1 times more data. So it's a lot of friction in that. I mean, obviously, a decade ago, it was kind of a problem of its own to just get access to the weather data. This problem nowadays with there are, I would say, many cloud providers that sells you the data directly on the cloud. So it's much easier. This part has become much easier, but crunching the data remains very complicated, especially because, again, this is not about crunching the weather data to do a weather simulation. It's about crunching the weather data to do something that is very, I would say, that still remain as super niche, which is to try to correlate this data with sales pattern. And again, just remember, weather is super local. For example, if you have an hypermarket that attracts people from a wide area, 30, maybe sometimes even 50 kilometers around, you don't have only one weather to consider. You might have to, to consolidate the data on a larger, I would say, geographical areas, but you will have to come to figure out all the necessary heuristics on your own.
And but we're sort of getting it very sort of complicated here and looking at different altitudes and looking at kind of different granularities. Is there not something a bit more simplistic we could introduce? Maybe something like a bit more reactive, like instead of maybe a min-max, you could have as soon as temperature reaches a certain amount of degrees, then you're setting an automated kind of purchase order. I mean, is that something like that not interesting?
I mean, it is interesting. Indeed, I mean, with temperature, you have, I would say, a first measurement of interest, absolutely. And indeed, you can start by focusing just on temperature, and average temperature that are average during the day. Yet, I mean, first, it's very far from reflecting, all you have to know. If I go back to the example of having, a spike of demand for meat because people expect to have a barbecue, if the next weekend is very hot but also very rainy and windy, you might not have such a good spike for your barbecue product. So it's, again, yes, temperature is good, but it's not the only thing. And then you have another problem that we also discovered as an insight is that your clients are watching the weather forecast just like you do. So what is interesting is that as soon as the weather forecast make it clear that this weekend or the weekend afterward is going to be, with high probability, a very nice weekend, then everybody knows it. And thus, you have clients that will start buying the product, the weather-sensitive products. And thus, if you just analyze the data with only like 1 or 2 days of lag, you have also an information about the weather. And remember that weather forecasts are not very accurate, beyond about 10 days from now. So you can't optimize with weather forecast decisions that are going further into the future than, let's say, 10 days, because after 10 days, you pretty much revert back to the seasonal average. So it's as if you didn't know anything. You just know that summer is hot. I mean, obviously, it's still something of interest, but it's something that is also very, very short-termish. And then just consider that when you, for example, enter a heat wave, like in Paris, the heat waves is maybe going to last for a couple of weeks. So the period of time where the forecast actually matter is not the 3 weeks of heat waves, because as soon as you have entered the heat waves, this is like a new normal. So the only period of time where it actually matters is just the 3 days where you are actually entering the heat waves, and then maybe the 2 or 3 days where you're exiting the heat waves. So it's very, very narrow point of time during the year where you even have an edge, truly.
Okay, so what you're saying is that window is very small, and actually collecting all this data doesn't really give us that much of a benefit. If we look ahead to kind of some of the supply chains of the future, if we're envisaging that one day we're going to have future weather forecasts that are incredibly accurate, they can look incredibly accurate into the future, and we've got greater control of our supply chains as a whole. Could you envisage that day where actually a weather forecast would be more useful?
Trying to leverage the weather data to forecast better, I mean, it's possible. Certainly, there are companies like, again, electricity providers who are doing that, I would say, with a very high efficiency, so that for them, the weather data is really an input that is very valuable, and that let them, refine their accuracy by quite a significant margin. But the interesting thing is that the most interesting use of weather data is not looking, into the future. It's actually looking to the past, and that's where, that was also one of the insights that we observed, is that, for example, if you are selling ice creams and you trigger, a new campaign, a new commercial campaign for your products, and it sells very well. Does it sell very well because the campaign was very good, or just because in Paris it was a heat wave and pretty much everybody who was selling ice creams had a very, very good period for this part of the summer? So that's interesting, because the weather data, when you look back, is something that is very useful to explain the demand that you observe. And here you don't have to deal with the intricacies of I would say, all the granularity you can aggregate, over a long period of time, like a week or two. You can aggregate over, extended geographies, and it will give you something that is very nice to, I would say, a very strong, explanation power. And by the way, that's also probably the reason why people, I've met many supply chain practitioners that were so enthusiastic about the idea of using weather data to refine the forecast, is that even if that part doesn't work out so well, it's because actually weather data is very useful and very to actually explain the past.
Okay, and how about things like climate change? I mean, we've got this understanding that the world's gradually getting warmer, and that's going to kind of affect our kind of seasonal forecasts going forward. So can we leverage this insight? Is that anything of use?
Unfortunately, you have, I would say, orders of magnitude at play. I mean, even, the most pessimistic, climate change prediction are considering something that over the course of the 21st century, we're talking of a couple of degrees of difference, which, by the way, if you think in terms of geological time, it is a very steep evolution of the climate. If you have if the Earth globally, heat up or cool down of 2 degrees over a century, it's a lot. It's very, very significant. But nonetheless, we are talking of a couple of degrees over a century. Even in a very, very mild climate like the one of Paris, temperature typically fluctuate between the highest point during the day and the lowest point is going to fluctuate of something like 20 degrees. And we have a very mild very mild climate. There is many regions in the world where the temperature fluctuates of 40 degrees between the highest point during the day to the lowest point during the night. So the bottom line is that having a climate change of maybe 2 degrees over the course of a century, when you think of how much change will it bring from one season to the next, it's literally vanishingly small. And when you think that most products, most consumer products are going to enter the market, so go from zero to their peak in something like 12 months and then disappear from the market 2 or 3 years later, you realize that the impact of, of climate is like super small for, as far supply chain optimization is concerned, just because we are not talking of the same time frame. Supply chain is about optimizing decisions for the next couple of months, maybe next year, maybe next couple of years if you have really big plans. But you're not, I don't think there is many companies who are thinking like centuries ahead, except in just being, more leaner and consuming less energy and producing less waste, which is a win for, obviously, the future. But it's not something that you really plan with a forecast.
So what kind of other data should we be looking at? What's kind of more important than the weather data?
Right now, we are still in the stage where, for most companies, they are not even correctly using their transactional data. That most companies we talk to, when we start working with them, they don't even quantify in euros or dollars their stock out cost. So they have stock is a trade-off between the cost of stock and the cost of stock out. If I'm simplifying. But basically, if you have, you're balancing 2 risks and you're not even assessing financially one of those 2 risks, it's very hard to optimize anything. So the first stage is to first do the most of your transactional data that is super reliable and that has exactly the granularity that matters for your supply chain decision. The second stage is to use all the data that is not transactional, but that is, easy to collect and still is very, very relevant to your own supply chain. So for example, that would be web traffic data. If you're a brand, you can look at how much visit every single page that you're posting on your website gets, and in particular, if you have pages that about your products, you can look at the web traffic. And again, when the web traffic evolve, you will get this information that is tightly connected to your own products, and that's something that you can use. Maybe a third, then again, a third layer of data would be competitive intelligence. What your competitors are doing, their prices, etc. That's data that is, more complicated to collect, but still very intimately, connected to your supply chain activity. And then beyond that, you have things like weather data and social data that are, they are possible. We have example of companies who are making use of those data, but they tend to be super tech-driven companies who have already gone through all the previous stages of exploiting, making the most of their transactional data, web traffic data, competitive intelligence data, and then you can venture into weather data and maybe social data and other sort of external sources.
Okay, so to sort of conclude today, maybe sort of weather data is useful and can be kind of interesting, particularly when looking into the past. But the main conclusion is basically that there's other things that are more important.
Yeah, and if you don't already have, a very large data science teams, you're not ready. That would be my message, is that you will know that you're ready when you're hiring your 20th or something data scientist and you don't exactly know what sort of new things to explore, then it will be a good time to start having a look at that.
Okay, we'll have to wrap it there for today, but thanks for your time. Okay, that's everything for Lokad TV this week. We'll be back again next time with another episode, providing we sort of survive this heat wave, and we'll see you again next time. Bye for now.